Hello my dear students. In the previous lecture we have discussed some of the questions related to NEET examination 2023 of your class 12. In continuation to that lecture we will discuss some more questions in the today's class. Now the first question is an AC source is connected to a capacitor due to decrease in its operating frequency. What happens? So the question is regarding a capacitor which is connected to AC source. Now we can see simply the circuit is we are provided with a capacitor that is connected to an AC source. Okay, this is the required conditions. An AC source is connected to a capacitor due to decrease in its operating frequency. So the frequency of this source is we know omega, and the frequency decreases. What happens? We have to calculate the value of displacement current and the conduction current. As we all know, conduction current and displacement current both are equal. The formula is V0 upon Xc sin omega t. V0 is the value of voltage, Xc is known as the capacitive reactance, and omega is known as the frequency. Now Ic is equal to Id. V0 by putting the value of Xc is equal to 1 upon omega c. On putting the value of Xc is equal to 1 upon omega c, we get V0 omega c sin omega t. Now, according to question, the frequency decreases. Now, if the frequency decreases, there is a decrease in the value of omega. If omega decreases, then Ic and Id will always decreases. That is option number 2. Displacement current will be decreased, because according to this equation, the conduction current, displacement current are proportional to omega, and if omega decreases, then there will be decrease in the Ic and Id. Now, moving to the next questions. The next question is related to hydrogen spectrum. The question says the shortest wavelength in the Balmer series is lambda. The shortest wavelength in the bracket series will be. As we all know, there are different types of wavelengths and different types of frequencies. According to that, we get different types of series of waves. So the relation is shortest wavelength in Balmer series ranges from infinite to n equal to 2. So we can put the values of initial values and final values. The formula according to Redbook formulas, 1 upon lambda is equal to r z square, 1 upon n1 square minus 1 upon n2 square. Putting the values, we get 1 upon lambda is equal to r upon 4. Now this is condition is for Balmer series. Now for the condition for bracket, we put infinite to n equal to 4. So replacing the values for 2 equal to 4, 2 to 4, and infinite will be same. The other equation is 1 upon lambda dash is equal to r upon 16. Now the question is related to relation between the wavelengths lambda dash and lambda. So from equation number 1 and equation number 2, we can get lambda dash is equal to 4 lambda. That is the required option number 1. In this type of question, we just have to write the formula for Rydberg relations and put the values of n1 and n2 according to the series. So we can get easily the relation between the maximum wavelength, minimum wavelength, maximum frequency and minimum frequencies. Now, the next question is regarding the rectifier circuit. We are provided within full wave rectifier. We know rectifier is a circuit used for converting AC to DC, and for rectifier purpose we are using diode. There are two types of rectifier, half wave and full wave. Full wave rectifier means full input and full output, and half wave means full input but the output is half. According to question, there is a full wave rectifier which consists of two PN junction diode, a center tape transformer, capacitor, load. Which of the following component remove the AC ripple? A ripple means unwanted signal. A ripple means unwanted signal. So we know the symbol of the waveform of AC is like this. But if the waveform proceeded like this form, this is known as ripple. This is known as ripple. Ripple simply means unwanted waveform. So the main purpose of to remove the ripple is concerned with the capacitor. The function of capacitor is to remove the unwanted ripples, and this is used so as to maintain a constant voltage at the load side, because capacitor opposes the rate of change of voltage. Okay, that's why it maintains a constant voltage level along with the cancellation of ripples. Okay. Now moving to the next part. The next question is related to magnetic energy. The magnetic energy is stored in an inductor of inductance 4 microhenry carrying a current of 2. The direct formula for the magnetic energy is half Li square, where L denotes the inductance and I denotes the current. The value of inductance is 4 microhenry, 4 into 10 raised to power minus 6, and the current is 2 ampere. So the square of 2, so we get 8 into 10 to the power minus 6, that can be written as 8 microjoule. 8 microjoule is the required option number 3rd. This is the energy stored in an inductor, half Li square. Now moving to the next part, that is related to Gauss theorem and Gauss concept of electricity and magnetism. If the line integral of E dot ds is equal to 0 over surface, then which of the condition is true? By observing the equation, we can say the line integral of E dot ds is equal to 0. That simply implies that net flux is equal to 0. The net flux is equal to 0. That means the flux entering must be equal to flux leaving. The number of flux entering and the number of flux leavings, the total flux entering and the total flux leavings are equal. So the option number 4 is the correct answer. This equation is satisfied by option number 4, that the number of flux lines entering the surface must be equal to the flux leaving that surface. If there are 10 entering and 10 leaving, the net value will be always equal to 0. So moving to the next part. So next part is related to the EM waves, that is electromagnetic wave. In a plane electromagnetic wave, we know electromagnetic wave is a combination of electric field and magnetic field which are propagating perpendicular to each other. Okay, it is a combination of electric field and magnetic field traveling in free space. The electric field component oscillates at a frequency of this. This is the value of electric field component, and the amplitude, this value, volt per meter. Then the amplitude of oscillating magnetic field is, we have to calculate the amplitude of magnetic field. We know the electric field and magnetic field are related by this equation, C is equal to E naught upon B naught. C is called the speed of light, E naught is electric field and B naught is magnetic field. So we have to calculate the value of B naught. We transpose the equation, putting the value of E naught as 48 and C is the speed of light, that is 3 into 10 raised to power 8. We get 1.6 into 10 to the power minus 7 Tesla. That is our option number B. Okay. So when the question is very simple and the question is direct formula based, you can see the answers are very close to each other. Okay. This is 1.6 into 10 to the power minus 8. This is 1.6 into 10 to the power minus 7. By just solving and by ticking on the correct is very important. If you are in a rush, then it may be there you tick on the wrong option. Okay. So before ticking on any option A, B, C, D, just observe the value and then tick. Okay, because these values are very close to each other. This is one of the sources of error in any examinations. Be careful before ticking, before selecting any options. Okay. Now moving to the next part. This is related to ray optics topic. The question says, what is the equivalent focal length of the combination of lenses? Assume all the layers are thin. Okay. So you can see in the diagram, we are provided with the combination of lenses. Okay. 1, 2 and 3. And we are provided with the refractive index of the medium. N1 and N2 are the refractive index and R1 and R2 is the radius. We have to calculate the equivalent focal length of the combination. So this circuit can be simplified in this form. Okay, you can see this is combination of 3 types of lenses, first, second and third. Okay, the values of refractive index are respective 1.6, 1.5 and 1.6, and the value of radius for the 3 lenses is this. This is f1 focal length, f2 and f3. We know the formula for focal length is 1 upon f is equal to mu minus 1, 1 upon r1 minus 1 upon r2. Now, just putting the value of mu as, this is the main formula for f1, f2 and f3. First we calculate for f1, then f2 and then f3. by getting the values of f1 and f2 and f3 and putting for equivalent value 1 upon f1 plus 1 upon f2 plus 1 upon f3, we get the equivalent minus 1 upon 100. So the required option is option number this. This is the value of required focal length of the combinations. Okay. Just the main formula is relation this, and because we are provided with 3 segment of lengths, that's why we have uses 3 focal length f1 and f2 and f3, and at last we have combined all these things. Okay. Moving to the next part. Moving to the next part is related to the xt graph of a particle performing simple harmonic motion is shown in figure. A particle is there which is performing simple harmonic motion. The acceleration of the particle at t equal to 2 seconds. We have to calculate the value of acceleration of the particle. Okay. So the xt graph is this. We have to calculate the value of acceleration. By just observation of graph, we say that the particle is having a sinusoidal graph. So for sinusoidal graph, we can write x is equal to a sin omega t, where a is the amplitude and omega t is the phase. We have to calculate the value of acceleration. So first we have to calculate the velocity. So the differentiation of dx upon dt gives us the velocity. So we have to differentiate this x. So by differentiating, we can say a remains a, sin omega t convert into cos omega t, and from omega t we get omega. This is the value of velocity. Okay. Now we have to calculate acceleration. So we have to once again differentiate the velocity component. So again differentiating, we get the acceleration value. Okay. This is the required value of acceleration. Now in options, we are not provided with this type of equations. So we have to put the values of this. So we have to put the value according to this. So the value of omega. So the value of omega comes out to be 2 pi upon 8, and putting the values, and the value of small t according to question is 2 seconds. Okay. So just putting the values, omega is equal to 2 pi upon capital T, and we can see the value of capital T is 8. That's why omega is equal to 2 pi upon 8, and solving we get option number 3rd, minus pi square upon 16 meter per second square. Okay. We just have put the value because omega is equal to 2 pi upon capital T, where capital T means the time period of the waveform. Time period means the complete duration of the waveform. Okay. And according to question, the small t is given as 2 seconds. Now moving to the next part. The next part is related to logic gate. We have to solve the equations using logic gate and then find out which is the correct answer. So we are provided with 2 inputs. One is the A and other is the B. This gate is NOT gate. NOT gate is also known as inverted gate. Inverter means which invert the input. If we provide 0, it convert into 1. If you provide 1, it convert into 0. Then this is NAND gate. Okay. We have to calculate the value of output. So when A goes in a NOT gate, it becomes A bar. It becomes A bar. And when B proceed in a NOT gate, it becomes B bar. Okay. Now A convert to A bar, B convert to B bar. Now this is NAND gate. This is NAND gate. NAND gate means not of AND gate. AND gate means simply the product. NAND gate means the product into reciprocal. So the output will be, it will be A bar dot B bar and complete bar. Okay. The output will be A bar dot B bar and complete bar. A bar is this value, B bar is this value, and this overall bar is due to this NAND gate. Now, according to De Morgan theorem, we can simplify the conditions as the overall bar will be split into both A and B. So we get, and the sign changes. So you can see the overall bar will be split into A and B. So A double bar plus B double bar. Okay. Double bar cancel out each other. So we get A plus B, and A plus B is the output of which gate? OR gate. So in options, we have to just identify the table which is replica of OR gate, and the replica of OR gate is option number 1st. That is our required answer. Okay. This procedure is due to De Morgan theorem of logic related to logic gate, that the double bar is unstable. It is split into single bar. into both the terms, and both the terms get double bar, and the sign changes. If it is multiply, it is converted into plus, and if it is plus, it is converted into multiply, and the both double bar cancel out each other. So the required output is A plus B, and we can say A plus B is the output of OR gate. That's why this complete circuit can be replaced by a single gate, that is OR gate. And if question asks about the symbol, we can then convert in the symbol form also. This is a symbol for OR gate. This is A, this is B, and this is Y. We can say output Y is equal to A plus B. This is the required solutions. Now, again the questions we have discussed, this is related to ray optics. We are provided with two thin lenses of same focal length f, but one is convex and other is concave. When they are placed in contact with each other, the equivalent focal length of the combination. We have solved this type of question that equivalent focal length is the combination of the two focal lengths, 1 upon f1 plus 1 upon f2. But one is concave and other one is convex. So for one we are taking positive value, convex, and concave is negative, and solving we get 1 upon 0, that is equal to infinite. That is required option number 3rd. Okay. Now, moving to the next part, this is related to magnetic field questions. A wire of current I along the positive x-axis has a length capital L. It is capped in the magnetic field is this. Okay. We are provided with this wire having a current of I, and it is put in a magnetic field of this value. The magnitude of force we have to calculate of the value of force. The value of force on a current carrying conductor is I L cross B, which can be written in the form of, if we simplify this, that is BIL sin theta. Now, putting the values of I as I, the value of L comes to be capital L, okay, and the value of B is this 2I plus 3J plus minus 4K. Just solving according to the rules of the scalar and vector product, we get F is equal to 5IL. That is required option number B. Okay, we have just solved the equation by using the concept of scalar product and vector product. Now, moving to the next part. The next part is related to the concept of resistance of wire. There is a wire material having platinum. The value of resistance is 2 ohm at 0 degrees Celsius and 6.8 ohm at 80 degrees Celsius. The temperature coefficient, we have to calculate the value of temperature coefficient, that is alpha. We know the relation is RT is equal to R naught 1 plus alpha T minus T naught. R naught is given values, first value is 2 ohm. So R naught is 2, RT is 6.8, alpha we have to calculate, T naught is initial temperature, and capital T is 80 degrees Celsius. Okay, so T naught is actually 0. So on solving for alpha, we get 3 into 10 to the power minus 2 degree per centigrade. That is option number B. This is known as the temperature coefficient of resistivity, or simply the temperature coefficient. This is formula used when we are provided with an resistance at a particular temperature, and we have to find out the value of resistance at another temperatures. Okay. Moving to the next part, the next question is related to electrostatics, dipole conditions. The question says there is an electric dipole. We know electric dipole is a combination of two charges having same magnitude but opposite polarity. So there is two charges, minus Q and plus Q, and the distance between them is around 6. O is the center point of the dipole. So O divide into two parts, left 3 centimeter and 3 centimeter. Now we have consider a point named P from 5 centimeter. How much distance? 5 centimeter from center of the dipole. Now the electric potential 10 raised to power 2 at P is due to dipole is itna. We have to calculate the value of potential. We have to calculate the value of potential. We have to calculate the value of potential. For calculating the value of potential, we can just read out the diagram. And now we have to calculate the value of potential at point P. Now you can see on P there is a potential of minus Q and there will be also a potential of plus q. So we have to define the distance separately. From minus q, the p point is 8 centimeter away, and from plus q it is 2 centimeter away. Okay, we just use the formula for potential V is equal to kq upon r. This is the required formula for potential due to a single point charge, and putting the values kq upon 2 into 10 raised to power minus 2, because plus q is nearer to point P, we first write the values of plus q charge, and then we write the values of potential of minus q charge, and solving we get kq 3 by 8 into 10 raised to power 2. Because point P, there will be potential of minus q and there will be potential of plus q. That's where we have calculated the net value of potential due to both the charges. Okay. Now we have not used the concept of K and Q, because in options the value of K is not solved and the values of Q is not defined. That's why we have written as it is in the question, as in the solutions. Okay. Now moving to the next part, the next question is also related to the concept of resistors. We are provided with 10 resistors, each of value R are connected in a series of battery of E and negligible internal resistance. Those are connected in parallel to the same battery. The current is ignited. We are provided with 10 resistors, each is having value of capital N. Okay, first it is connected in series and then it is connected into parallel. Okay, first it is connected in series, then it is connected in parallel. Then the current increases N times. As we all know, in series combination, the total resistance add up. That's why it reduces the current. But in parallel, the value of resistance decreases. Hence the value of current increases. That's why the value of current increases N times. Now, the formula for series current is equal to, according to Ohm's law, voltage upon resistance. Is equal to E upon 10R. Okay. Now the formula for parallel is E upon R upon 10. Because in series the resistance is directly added, and in parallel the resistance is added in 1 upon times the normal value. So the first equation is series current and other is parallel. Now we have to, according to question, the current increases N times. So N is equal to IP upon IS. So we get 100 values. Okay. So the value of current increases 100 times as compared to series. Okay. The next question is also related to magnetic field concept. Question says, a very long conducting wire is bent in the semicircle from A to B as shown in figure. You can see there is a very long wire that is shown by the dash portion. It is bent in the form of semicircle from A to B. From A to B it is the form of semicircle. That's why it is having a radius R. Okay. The magnetic field at the point P for steady current configuration, if we have to calculate the value of magnetic field at point P, we can simply use the formula B is equal to mu naught I upon 4 pi R minus mu naught 2I upon 4 pi R. Just having direct formula for magnetic field, we get the solution as this. This is the required option number 2. 1 minus 2 pi, that is directed away, or we can say directed away from the center. Now, the next question is again related to the series question, spectral series. The radius of innermost orbit of hydrogen atom is this. What is the radius of third allowed orbit of the hydrogen? Okay, this is the direct relation. Rn is equal to, Rn means radius of nth orbit is equal to 0.53 into n square upon z. We have to calculate the value of third orbit, so we put n equal to 3 and z equal to 1 for hydrogen. We get 4.77 angstrom. That is option number 3rd. Okay, this is the direct relation. If in spite of third, if we have asked about fourth, fifth, seventh, we can easily calculate by just replacing the value of n. Okay, the next question is related to RLC circuit. We are provided with an RLC series circuit. The value of L is 50 upon pi millihenry. The value of capacitor is 10 to the power 3 upon pi microhenry, and the value of resistance is 10 ohm. We have to calculate the value of the net impedance. We all know if in a circuit resistance, inductance and capacitance are all present together, then the combined circuit is known as impedance circuit. Okay, the hindrance offered in the path of current by the collective effort of resistance, inductance and capacitance is called impedance. We have to calculate the value of impedance. Okay. So as we all know, the formula of impedance is Z is equal to R square plus XL minus XC whole square. Okay. So firstly, R is directly provided in the question, 10 ohm, but we are not provided with XL and XC. Okay. So we have to calculate the value of XL. XL is equal to omega L. XL is equal to omega L, and XC is equal to 1 upon omega C. Omega can be written as 2 pi f. Omega can be written as 2 pi f. So we can see 1 upon 2 pi f c. The value of frequency is 50 Hz. By just putting the values of frequencies, and we get XL is equal to 5 and we get XC is equal to 10. On solving, we get impedance is equal to 5 root 5 ohm. That is the option number 2. Okay. And on solving, if we get XL and XC at equal values, so we can simply say it is a condition of resonance. Resonance is a special condition of series RLC circuit in which XL and XC are equal to each other. Okay. This is simply the calculation of impedance. The next question that can be asked about this type of circuit is regarding the current. So how to calculate the current? Current of series circuit, a series RLC circuit can be simply computed as I is equal to V by Z. I is equal to V upon Z. This is a simply calculation for impedance of an RLC circuit, and we can easily calculate the value of current also. Okay. Okay, this is all about the solution of today's slide, and we have discussed the different questions that have been asked in NEET 2023. In the next lecture, we will discuss some more questions of the NEET examination. Thank you.